All right, so welcome to this last presentation before lunch. It's going to be a presentation about progressive web apps. This is a topic I first encountered about 1.5 years ago, and since then I looked at a lot of talks and a lot of videos online, and I'm really, really excited about it. So, without further ado, let's jump into our journey, which begins in 1995, when JavaScript was created by, as you know, Brendan Eich at Netscape. Then 2 years later, it gets standardized at the ECMA committee in Europe. And then comes a period in which JavaScript starts to gain traction. It becomes more and more popular, but it's kind of slow. So in 2007, Chrome starts working on its V8 project. This is the engine behind their browser, Google Chrome. It's the engine that runs JavaScript. And right after that period of intense innovation comes in the JavaScript world from 2008 to 2010. They call it the race for speed, in which all the top browsers innovate in this department of speed, and they beat each other month by month. So, 1 month, let's say Safari is on top, and then Google Chrome comes, and then Firefox, and so on and so on. 2009, AngularJS and Node.js hit the market, and then, as we know, things start to heat up in the JavaScript world. 2013, React. 2014, Vue.js. And now, in 2018, there are more than 5 billion devices connected to the internet through the World Wide Web. So basically, the web is the biggest distributed platform, let's say, for applications in the world. And I think it's the best platform out there. And let's see some points on why I think the web is the best. First thing is that it's everywhere, okay? So it doesn't matter the device, it doesn't matter the browser. I don't care if you're on desktop or on mobile, if you're using Chrome, Firefox, or Internet Explorer, you're gonna see my app. And all I have to do, I have to put it out there, and it's for the world to see. More than this, I don't need approval from Google or Apple or Windows in case of native apps. I don't need Google to tell me, okay, you're approved. I just buy a home online, I put there whatever I want. Then the internet or the web apps don't require an installation, right? So you don't have to go through 50 megabytes, or in terms of Facebook Messenger, I think it's about 200 or 150 megabytes to install it, and then you can use it. Okay, just go online and it's there. And another reason why I really like the web is because it's extremely powerful. So you can do a lot of things in the web. And more than this, like Dragos said in the first presentation of the day, now with augmented reality and virtual reality coming to the web, it really is a platform where you can do anything. Right? You can build web apps, you can write server code, you can even build mobile apps, desktop apps, AR, VR, so it's a really powerful platform. However, and of course there's a however in this talk, it doesn't work without connection. Okay, so if you don't have connection, or if you're on a slow connection, the experience kind of gets really crappy. And this again makes sense, because when Tim Berners-Lee invented the web in 1989, it was just a document viewer. So you would see documents on another person's machine, and well, you kind of need connection. It's in the definition for you to see documents on that person's machine. However, now when we think about web in terms of web apps, it would be kind of cool if we could, see something even if I'm on no connection. Now I told you it doesn't need an install. The downside to this is that it kind of installs every time. So the HTML, the JavaScript, the CSS, they get downloaded, parsed, and ran every time you go on the website. And the last downside I want to mention, and this is like the other two are, I have data on this. This one is more of my opinion. I've seen that it's still not the norm on mobile devices to have web applications. So people still kind of expect you to have native apps, to download them. They are on their home screen. This comes from my experience as a freelancer when I've talked with a couple of business owners and also a couple of people, like non-technical people. And when they heard, okay, when I said to them, we can build a web app and it's going to be responsive and it's going to be just as fast, they were like, yeah, who wants to, put something in the browser bar? Who wants to open the browser on the phone? I want it to be an app. I want it there on my home screen. So I still feel like the web isn't the norm on mobile devices. Part of the reason, I think, is that when iPhone debuted in 2007, the web app wasn't as powerful as it is now. So I think native apps had a first start on that, and that's why they're kind of the norm. Okay, so this is the web. It has some good parts, and again, the one which I find really, really exciting is that you can just take your creation, put it out there for the world to see. You don't have any middleman or something like that. It has some bad parts as well, which, and I'm sure some of you guess where this talk is going, some of these bad parts are completely erased by progressive web apps. Okay? Now, what are progressive web apps? Well, it's just a term for a special kind of web applications, like web apps with superpowers. And they have a really interesting mentality behind them. So when you want to build progressive web apps, you have to think in a certain way. And that way is kind of like this. Instead of waiting for all browsers to support a feature or an API or something, why not use it if I have access to it, if my users are using, let's say, the latest Chrome, and I have it there. Let's use that feature. If the users are on an older browser, okay, I don't have that feature, but the app still works in a, well, old-fashioned way. So that's kind of the mentality behind it. Let's not wait for everything to be implemented across browsers. Let's just use it where we can. If we're in a browser where we can't use it, well, the application shouldn't crash, and it still should be a normal web app. This term was coined by those guys, Alex Russell and Francis Berryman, while they were working at Google. I think Alex is still working at Google. And what's exciting about them is that those superpowers, and I will have a demo in like 2 slides, those superpowers that I tell you about bridge the gap between web and native. And this is really important also because mobile traffic has long surpassed desktop traffic. So we are going online more from our mobile devices, from phones, from tablets, and so on. So kind of mobile is like the new desktop. So you need, it's more important than desktop now. And another thing about progressive web apps, because they are JavaScript native APIs, they don't require a special library or a special framework or something like that. They're at bottom, let's say. So you can use or you can implement progressive web apps with Angular, with React, with Vue, with whatever your framework or library is. Okay, so those are native JavaScript things. Doesn't matter what you're using for your app. Progressive web apps can be built with anything. So, without further ado, let's see a progressive web app in action, and I will just take the chair right now and show you. So let's go online, and this is the app. It's just a chat app, nothing too, nothing too spectacular. It has here a, the place where you input messages. Okay, now let's see the first thing. I told you that the web needs connectivity to run. Well, with progressive web apps, you can build applications that work offline. So let me just open DevTools, and I go here to my network. I will just put me offline. So let's just control zoom here. Okay, you can see the offline button is clicked. Let's just check I'm offline. So I go to Google, we have the dinosaur, okay, you can play the game here, whatever. I still go to my website, okay, and it renders, it's here. Now, of course, I cannot use it like a chat app because I don't have connectivity. You can't see, thank you. Okay, let me just see. Is now better? A little bit? Okay. Now you can see here the forbidden sign at the top. This is telling me I don't have a connection. And if I try to write something, I'll do it in a moment. It will not work. But the important thing is my HTML, my JavaScript, or a little bit of JavaScript, and my CSS comes. Okay, so I can see stuff. And more than this, I have the messages cached. So if I'm in the mountains and I want to see the last message, I go here in the app without connection, and the last messages are here. Now let's see another cool part. Let's say I want to write something. So in terms of a chat app, I write a message, I'm on no connection. I don't want to stay there and refresh and try again with my phone in my hand. I would like the web to send it in the background when it gets to internet. Okay, so I just want to put it in my phone. Let's just go ahead, it will send it. So let's try this, and hopefully it will work. I will disconnect, and I don't see the. Wait a second. I don't see the Where is my app? Here. Okay. So let's disconnect from the browser. Let's F5 this. I'm offline and say from offline. And you see the messages. The message is well, you can't see the message. Let's do this. The message is styled differently, and it says it's not sent. So right now it's just on my machine. If I connect again, and let's just close the page. This is also really important. I close the app entirely. So the app isn't in the background, or it's not there, you know, we've connected to the server. It's closed entirely. I close the tab. So I just go here, and let's connect to this. And now if everything works properly, we should see a notification coming telling us, there it is. You can only see half of it. The notification says messages have been sent in the background. So, you know, I have connection with my device. The app is totally closed, and this works on mobile as well. And behind the scenes, it sent the messages and it notified me, okay, send your data. Now you've seen this notification. This is another thing, so it works offline. It can also receive push notifications, and I have here the mobile variant of the app as well. And let me just write something here, say, hey, CodeCampers, and I just send it, and I should receive, there you see it, hey, CodeCampers. Okay, so I have notifications, and those are like real notifications. They work even with the app closed. They won't work if the browser is closed, however. We will see why. They work on mobile as push notification. This was a big debate between web and native, because web didn't have push notifications, it didn't have a way to re-engage you, to tell you stuff. Native always had them. Now the web has them as well. And the last thing about this app, this web app, which again bridges the gap between web and native, it can be installed. I will show you how it can be installed even on desktop. For mobile, I have some print screens. So I don't know why. Oh, I see it here. So I have here the button Add to Desktop, and you see I have an icon there and the name. And I said, okay, add it to my desktop. And if right now I go here and search for that, somebody said hi. Thank you very much for using the app. You can see here this is the icon. I think my laptop is running slow because I put some recording piece of software which records the screen. I think that's it. So this is the app, and if I click it, should I dare to click it? Let's just try. If I click it, you can see it opens without the browser bar. Again, this isn't so impressive on desktop because who wants to install things on desktop? But on mobile, you can think that it will have a home screen icon. I have print screens of that. It will have an icon. It will open in full screen without the browser, which makes it look to users exactly like a native app. Okay, now that I've shown you this stuff, let's get back to the presentation. So we've seen the demo. So those are the three features I showed you. Let me just check. I have. This is where. Okay, so the app works offline. The app is app-like in terms of it can be installed, and the app is engaging. It can send push notifications to you even if you're not using it. Now, all of those pieces of, or all of those features, let's say, are only available, or at the root they have a special kind of JavaScript file, a service worker. Now, if you don't know what the JavaScript worker is, that's just a separate JavaScript file running separately from the main thread. So if you think you have an app which receives a photo, you upload a photo and it just turns it to black and white on the client. Okay, that would be a lot of processing required on the client. So you'd have to take each pixel and change it to black and white. If you have a 10 megabytes image, there will be millions of pixels. So if you do that on the main thread, the application will block and you will see the not responding spinner, something like that. Workers are used to do some computation on a separate thread, and then you can communicate just the results with them. Now the service worker is a special kind of worker, which kind of acts like a middleman between your app and the internet, or like the outside world. And because of that, it can enable it to work offline, and it can send push notifications to it. This is how everything looks like. So I have my browser there. I have the service worker on the client side, because the client is on the left side. So it's on my machine. It's running separately from the app. That's why, again, I'm guessing you already guessed this. That's why I can receive push notifications even if the app is closed, because the service worker is not closed. It's running in the background. Okay, let's get into some code. I will show you some code examples, some minimal code examples. Again, this is a huge topic you can dive into. I just want to show you what's possible, and I hope to get you excited about what's possible in the web today. So let's see some code. At first I told you that we use those superpowers only if we have them. That's really important to keep in mind. So the first piece of code, if we want to register a service worker, is to actually check that we're in a browser which supports service workers. Alright? And if it does, we call navigator.serviceworkers, and somebody wrote the push notifications, which I cannot read. Navigator.serviceworker.register, and that's a promise. Again, if you don't know what promises is, we're not going to dive into today, but just if it succeeds, it will log the success message. If it fails, it will log the error message. Okay, let's see it in action. So I have here the app without any progressive stuff to it, so just the basic app. And if I go to app.js, I have here the service worker code, which is commented. And let me uncomment it. Start the server. And what's going on? 1 second. npm start. Okay, it's starting the server. And if I go to localhost 4000, I open up the dev tools and I go to the application tab, and I have service workers here, the new, or in Chrome, that's where it is. And I have here my service worker, which is registered. I click on it, it's an empty file, but that's okay. I have an empty service worker. So that's the first step towards doing towards making my app progressive. Good. Now that we have a service worker, that was step 0, let's see some cool stuff. And that's how we make our app to work offline. And I have here a small diagram of how, let's say, the web works. So we have a server which has some files on the server. And I go to example.com, I make a request to the server gets those files, it sends them back to me, and the browser shows them. If I don't have connection though, I cannot go to the server for those files. So what if I could save those files on my side of the, let's say, equation, so on my computer? That way I don't have to go to the server every time for them. So this is basically the mentality behind how they work offline. We save the files on our machine, and that way, when we go on example.com, the browser will take them directly from our computer. Okay? This has two big advantages. And let's see. 1 second. Okay. This has two big advantages. I thought I had. Oh, I have that one here. It wasn't appearing on my phone. So the first one is, okay, it works offline. Now maybe you want that, maybe you don't want that. Or what you can do is, when I go on your app and I'm offline, you just show me a message saying you're offline, you need connection. We can do that. But the most important advantage is the performance aspect. So if the files are on your machine and the browser takes them from there, you don't have to go through the network for them. So you don't care if you're on 3G or 2G, or you're in the mountains and you get connection, or you don't get one. They're on your machine and they will load up instantly. This is a huge, huge performance boost. Again, ourselves here in Iasi, if you're on a wired connection, or if we're on Wi-Fi in cafes around the city, this doesn't really matter. But as this guy said, and it says basically, it's a guy from India, it says he doesn't have, he has only 2G internet, and there at the bottom says, opening Gmail in basic HTML, so the basic version of Gmail, takes 30 seconds to a minute. Okay, so that for that kind of person, for the persons coming from those emerging markets, or India, Bangladesh, and so on, they really have shit connections. So they're like really have, and imagine if they had the files on their machine, it will boot up. There are two steps to the equation. The first one is we got to cache the files. The second one, we gotta get them from our computer when we need them. This is what I want. I will show you some code. It's kind of a messy piece of code. It involves promises and chains of promises. So if you don't know what the hell that is, if you look at the code, like, what the fuck is this? Just remember those two steps. Okay, we cache the files, we get them from the cache when we need them. That's all there is to it. So, come on into that. 1 second. I'll do it like this. Okay. So, so we have there a variable in which we put the names of the files we want to cache. So I want to cache the root and my style.css file. Okay, there's line 1. And then in the service worker, so this code goes in the service worker, I have an event which is called install while the service worker installs. I'm not going to go into that. Again, this topic is a really big one. Basically what we do is that we open up a cache and we give it a name. So the name for my cache is static files. When that cache is opened, I go through each string in my variable. I make a request to the server for it. So I fetch that fetch on line 10 or 11 is basically, okay, I go to the network, I get the files. When the response comes back, I put them in the cache. So there at line 12, I put the responses in the cache. Now on the other side, now that I have them in the cache, and actually let's show here the demo. I have here my code, which we're going to copy in serviceworker.js. And there it is. Let's go to the browser. Let's just click this so that the service worker updates every time. And now, can you see the cache? Yes. Now here in cache, you can see I have a cache called static files, the one which I created. I go to it and I have two files here. I have the root, like the index.html, and I have my styles.css. So now I've cached them, they're on my machine. Let's see how do we get them from there when we need it. And yeah. Okay, I will do it like this. So, in the service worker, there's a fetch event. Again, it's in the middle. It's between the browser and the internet, so I can intercept all requests coming or going. So when a new request is coming, I intercept it. I have to clone the request. That's because you can't use a request object twice. Don't worry about that at the moment. So basically, this is the important code right there at line 9. For each request, I go caches.match for that request. So I search that request or that file, whatever it is in my caches. And when the response comes, I either return the result, that's on line 14, or if the result is undefined, rest there is undefined or null, I make another fetch to the network. So this is kind of a safe mechanism. I'm saying, okay, for each request, search it in the cache. If it's not there, let's try to get it from the network. Just, maybe something messed up, we didn't cache it, let's get it from the network. So let's see the second part. I have here the code, and let's copy this again in my service worker. Okay. Let's have 5 things. Let's see that our service worker has the code. It has it. And now let's just look over the network. And let's style.css. You can see here in the DevTools that it says coming from service worker. So now that request isn't going to the server. It's actually, I'm responding to it. Let's check that we are actually working offline. So let's go offline. Now I'm offline. Let's go google.com. Doesn't work with my application. There it is. Let me even close the server so it's not any question. Come on. Okay, I close the static server. And here is my app. Again, I didn't, you can't see all of it. So this is it. Again, it's messed up right there because I didn't cache the images. I didn't cache the messages in the real app. I did that, but I just want to show you that you can take files or even data, cache them on the client, and then when you go on that URL, you serve them from there. Okay, and here in a real use case, I could, like I did show the past messages, or If your app doesn't have something like this, show a message saying you need connection for that. But it's still better than the Chrome tags. Okay, let's go back. Let's start the server again. And let's go back to it. Aha, now it's working. Okay, so this was the first one. Having our apps work offline. Again, the two biggest advantages for this is that number one, our app is much more performant. Doesn't matter for us, it matters for people in emerging economies. And secondly, it can work offline. That's really helpful when you just want to check, let's say, the CodeCamp schedule, and you're here at -1, don't have internet, but it's still there. You can still see it. Now, the second advantage to this is that we can make web apps app-like. That's much more simpler than the past piece of code. We just need to add a manifest file to our index.html. We need to link to it. This is basically a file describing our app. This is how it looks like. So we have a name, short name, some colors, background color, and the most important thing, or among the most important thing, is the icons property, in which we put an array of icons at different resolutions, so that it will look good, even on the highest resolution font. So we just put this file on our, let's say, client. We link to it in the HTML like this, and let's see some screenshots. And I will show you screenshots because it will be cumbersome if I connect my phone to it. So if I go on Geeky and find a GitHub.io or the URL, Chrome suggests me to install the app. So you see this is shown by Chrome. It's not me showing this pop-up, it's actually Chrome saying, okay, you have the manifest, you have all the conditions to install it, do you want to install it? Then if I install it, this is how it looks like on my phone. So there in the bottom right, you see it has an icon, just like a normal app. When I open it, it opens without the browser bar, and it has a splash screen, again, just like native apps. And once the splash screen goes away, this is how it looks like on my phone. Again, no browser bar, nothing like that. So to the users, it will look exactly like native apps. Yes?
I tried it now on iOS, installed it on the home screen.
Yeah, iOS.
It's just on Android like this?
No, so basically the manifest.json standard now isn't implemented in iOS. It's just in Android and I think Windows.
Will it be?
Yeah, but that's different than the manifest, the meta tag. Okay. Yeah, but so basically there are some tags in the head in which you can use this in iOS. The manifest.json file is a wannabe, or I think it is standardized, but it wasn't implemented in all browsers yet. So before Apple still has some tags you can put some special Apple tags so that it opens up like this. But soon we won't need to do that. We will just have the manifest file and it will work. Right now it works on Android, on Chrome, it works on desktop again with Chrome, it works on Mozilla, on Firefox, and it will soon work on iOS as well. All right, and now the last piece of, let's say the last goodie I'm going to show you. Our app is engaging. So this means we can send push notifications to it. And before we dive into the code, I think it's important to see how exactly are push notifications working. How exactly can we receive something even if the app is closed, so there's no WebSocket behind, or whatever connection there happening. So if I got a server, I have my app running in the Chrome. That's why the black square right there, that represents that I have a tab inside Chrome. When I close my tab, the connection with the server goes. So the way we send push notifications to a device is that we actually communicate with a third-party server, so like Chrome server or Firefox server, something like that. So each browser which implements push notifications has their own server up there running 24/7. So my server will talk to the Chrome one because I'm on the Chrome browser, and it will say, hey, I want to send a push notification to this device. It will have an identification. Then Chrome server will talk to the Chrome browser. This is why I need the browser to still be open. So it says, okay, I got a request for a push notification. This is the data. The browser then talks to the service worker for my app, which running on a separate thread is running even if the app is closed. And the service worker will display the notification. Right? Like the interesting part here is that all browser vendors, Chrome, Firefox, Safari, which I don't think it has implemented this yet, all of them have their servers online. Now to look at some code, I use Firebase for the backend part just so that I don't write my own server. If you want to try playing with this, Firebase is a cheap, very easy alternative. And this is the important part. I first have to request permission for my user to show him push notifications, and nowadays all apps seem to do that, even though they shouldn't. So don't bug your users too much. If the permission is granted, then I get a token. This is an identification token for myself. And right now I'm just logging it to the console. In real life, you would send it to the server, to store it in the database and be like, okay, this is the ID for this user. Let's just copy and paste the code and see how it goes. So I have here, and if I go in app.js, and I will have to put this here in the registration. Let me just, okay. Now let's double check. Let's see that everything is working. And you see here I have the token. Can you see? Yes, perfect. So right now I have accepted. Let's just delete the permission, refresh the page. This is how it looks like on Chrome. Funny side thing. Some browsers will show you a permission which doesn't. Yeah, you can see. Why don't you guys say? Well, you can't see that. And you still. Jesus Christ. It's that one. Okay. Okay. So this is how it looks like, the real one. What some web apps are doing, they show you a fake notification request. So they show you a pop-up made by themselves. If you only click yes, they will show you the real one. The reason behind it is that if I block something, it's blocked forever. So you cannot ask me again for a permission. So that's why they're doing this trick. They show you one they made. If only you click yes, then they show you the real one. Because they're like, oh, this guy wants the notification. Okay? If you click no, you didn't neglect the real one. So what I've been doing lately, I click yes the first time, and then I click block the second time, like, yeah, fuck you now. All right? Okay, so I have this... I have the token here. Let's allow, and I have the token here. Let's see what we do with it. If it will work, and we still have still 10 minutes, which is good. So we need to listen for the push event in our service worker. And when some data comes, again, this comes from the server, we use self.registration.show notification. So we show a notification with a certain title and a certain button. So let's do that as well. I have here the service worker code. I will put it here. And there it is. And now, okay. And now, to test it, or what we would do on the server side, I wrote here a small snippet. I do not, this one is, or push snippet. And you see, I'm actually making a post request to, let me just zoom in. I'm making a post request to the Firebase server. This is my private authentication key from the server. And this is where I would put the token. You see, I have here 2, and I put the token from the client. So if I just take this one from here and put it right here, and let's say a title, launch web app view. Okay, and I click Control Enter. You see the notification came. Here I have the response from the Firebase server that everything is okay and so on. So it's not too high tech. You just need the permission of the user. You take its token, store it in the server, in the database somewhere. When you want to send notifications, you just do like a simple post request to the, in my case, Firebase server, because that's what I'm using. And we've seen the demo. So now on the final stretch, come on internet. Doesn't want to show. Okay, yeah. This is the how I felt first when I saw a presentation like this, like 1.5 years ago. So okay, everything is cool, everything is nice, but now what? Okay, we're gonna finish the presentation, we're gonna go home and what? So, I first hope that I made you excited about this, that I showed you some stuff that the web now can do, and it wasn't possible until some time ago, and it really helps us compete more with native apps, and it helps us deliver better experiences to our users. Now, if you're excited about this, I would strongly recommend you follow those guys. So Alex Russell, Jake Archibald, and Eddie Osmani. If you don't know about them, well, you should. You know now. Follow them on Twitter. They're really pushing the web forward. They're really working on the progressive web app standard and so on. And what I have here, that's the live URL of the app. I also have a Facebook page where I did a workshop on regarding PWA. It doesn't matter too much right now. But the point is, the code for this app is on GitHub. It's public. The app is online. It's public. So you'll just go there, play with it, and then implement some PWA awesomeness in your apps as well. And question now. Yes.
Is there anything more you can do with the notifications, like something else except for dismissing? Like, can you have some action buttons maybe?
Yeah, you can. So you can, if you click on them. Yeah. So I will repeat the question just in case it wasn't heard in the back. So the question was, can we do anything else with notifications except dismissing them? Well, one thing I didn't show you is that if I click on the notification, it opens the app. So I implemented this in the current app. There are also some properties you can add regarding buttons, but I'm not sure if they're supported in all browsers on all devices. So like the basic stuff, the body, the title, an image, that's supported everywhere. But again, there are some things that Chrome allows and Safari doesn't and so on. But the click definitely is there. And you can even, what's interesting is you can even know if you're on the web app right now, so that it will not show your notification, let's say, if you're in the app. So if I'm right there looking at the app, I don't need a notification. I see it changing at my app. Anything else? Yes?
Yeah, it's still regarding the notifications. On Windows, I saw that there was like just the text, but maybe you can add, I don't know, images also to the notification.
You can add the icon of the notification. So in the real example, you saw the geeky and fun icon. You can also add images as part of the body. Just, yeah, you will see there are a lot of fields. You can add them. Again, you need to check each one if it's supported across the board. Some of those technologies are still kind of experimental, so that's why they behave differently. But they're all on track to being standardized, if not standardized already. Yes?
Are you able to create your own push server, or you have to use the Chrome one?
Yeah. You can create your own push server. I did some research on this. It seemed overly complicated.
Yes, but it's privacy. It's about privacy.
I know. Well, you still need to interact with their third-party servers, so you need to still interact with Chrome server. But instead of using Firebase like I am now, yes, you can implement your own. I just looked into it briefly, and it seemed too complicated to try. Okay. Yes.
Is there like a smart mechanism for the caching part?
No. This is exactly what happened. So basically, in the past, there was a thing called app cache, which did kind of the same thing. So you would put some files there, and it would cache them on your machine. But with this API, with this caching API, which I create the cache myself, I get it from there, I have full control over how my application behaves. And this enables me to do some really custom logic. So maybe my app requires it, or maybe in my app I want to check the network first, and then get it from cache if it failed the network. Or in my case, I get it from cache first. If it fails, go to the network. Or maybe get it from cache only